We live on a small island of life, floating in an ocean of darkness and violence. Orbiting us are gas giants, worlds of acid, and frozen deserts. For decades, the eyes of humanity, Hubble, Cassini, and James Webb, have captured the beauty of this neighborhood. Subscribe and join us on this journey through our solar system. Before rock, before ice, and before life, there was fire. Our journey begins at the very heart of the system, the Sun. It is no simple sphere of static light. It is an unstable nuclear reactor, a perpetual storm of plasma and magnetism. To grasp its scale, the Sun holds 99.8% of all the mass in the solar system. It could swallow 1 million Earths inside. Observations from NASA's Solar Dynamics Observatory, SDO, reveal a surface in constant boil. Every plasma arc and solar flare is a brutal release of energy, shaping the system's magnetic fields. The real danger lies in the solar wind, a torrent of charged particles flowing at hundreds of miles per second. This wind would sterilize any world if not for the first and most crucial line of defense, the planetary magnetic field. Upon impacting our magnetic field, this radiation is deflected, giving us the spectacle of the auroras, a visible reminder of our protection. Let us leave the engine of the system. The power of this star has already scorched its first victim, a defenseless world facing the Sun alone. After the fire, the first rock of the system, Mercury, the smallest and fastest planet. With barely a third of Earth's gravity, this world is subjected to the most extreme temperature variations. In the sunlit regions, the thermometer exceeds 400 degrees, melting lead. At night, it drops to 173 degrees below zero. Despite everything, deep within its polar craters, which never see sunlight, ice exists, frozen water, protected by shadows. The global effort to understand this world continues. Missions like BepiColombo, a joint project of the European Space Agency, ESA, and JAXA, seek to unveil the composition of its dense core. The next world is Earth's twin in size, but it is, by far, the most hostile place in the system. From the outside, Venus is a planet of serene beauty, a white sea of clouds reflecting sunlight. From within, it is a hellscape. Its atmosphere, 100 times denser than ours, is composed mainly of carbon dioxide and sulfuric acid clouds. NASA probes, such as Magellan, have mapped its surface with radar, revealing a world of thousands of volcanoes. However, only one nation has managed to survive that environment long enough to send an image of its surface. This is the rock of Venus, a place where the pressure is equivalent to being submerged 900 meters under the sea. These conditions destroy any probe in less than 2 hours. The runaway greenhouse effect of Venus is a cosmic warning. Let us leave behind the acid fire and seek the oasis. The transition is brutal. 160 million miles from the fires of Venus, we find the anomaly, Earth, our home. The third planet is, at this moment, the only known place where inert matter organized into something more: life. This miracle does not reside in the oceans alone. It resides in this thin blue layer, a unique atmosphere that retains heat and allows for liquid water. Life flourished thanks to a narrow margin of balance. The planet achieved its orbit at the precise temperature, keeping water in a liquid state, the most fundamental requirement of the cosmos. And this balance is guarded. The Moon, our oversized satellite, is the stabilizer. It slows the wobble of our axis, tames the climate, and gives us the seasons. It is a reminder that, even in the vastness of space, life here is the rarest jewel in the Milky Way. Let us leave the refuge behind. The next world, a crimson desert, is perhaps the promise of our next frontier. Mars. Even within the habitable zone, Mars is a universe of sand. The fourth planet is the promise of our expansion, and the wound of a world that lost its chance. Today, the Martian surface is inhabited by the eyes of humanity. NASA's Rovers. Their panoramas reveal a seemingly dead desert, but the drillings of curiosity and perseverance tell a different story. Key findings indicate that Mars was, in the past, a blue world. Billions of years ago, vast oceans covered its plains. It possessed an atmosphere and a magnetosphere that, for reasons still being investigated, collapsed. The geological evidence is overwhelming. Ancient riverbeds, canyons, and minerals that only form in the presence of liquid water. In this search for ancient water, the European Space Agency, ESA, has been fundamental. The Mars Express probe has found evidence of vast ice reserves beneath the surface of the South Pole, and the technology does not stop. We have achieved the first controlled flight on another planet thanks to the Ingenuity helicopter, proving that colonization is a real possibility. Mars is accompanied by two anomalous satellites, Phobos and Deimos, two captured asteroids that remind us we are at the edge of a transition zone. Millions of rocks and minor worlds, such as Ceres and Vesta, orbit like the remains of a planet that never quite formed. We have crossed the threshold of the rocky planets. Between us and the gas giants lies the main asteroid belt. This vast ring is a reservoir of billions of rocks and minor worlds. A debris belt that marks the true boundary between the intimate and the colossal. But this boundary is dominated by a force that rules the fate of the entire system. Jupiter, a gas giant containing more than twice the mass of all the other planets combined. Its mere existence has shaped the course of Mars, of Earth, and of every object we have seen. Its gravitational force is a constant threat, and its beauty is matched only by the danger it represents. Subscribe so you don't miss Part 2, The Path to the Gas Giants. Thank you for joining us on this journey through the solar system.